Hello everybody. Now let's look at the hardware. So the hardware is a small piece. The top is the driver, the middle is the CPU, and then at the bottom part there is the display. This is the supply, connect directly to the board, and then this is the on-off switch for the supply, and this is the motor. There's a plate installed on the rotating axis, and at the back there's an encoder to read the rotary position. And this is the connection to the computer, okay? By plugging in, and then you directly connect to your computer. So to start, we don't need to connect anything but the supply. So we switch it on, and then you see the display. So you see these are the display. This is the target position and the current position. I'll switch it off, and then we connect to our motor. And then switch it on and see what happens. Right, now motor turns to position 500. And then this is the jumper setting. Remember, don't set it wrong. Okay, so this is the quick introduction. Later we'll talk a bit more about this. So long. Okay, hello again. Today we'll get a demo on the PID speed control. So first we switch on, and you see the target is 20, the velocity, and then the position will quickly go from 0 up to 20 and remains there. We try to increase the speed. We increase every increment is +5. So we pressed 30. It will slowly go up to 30, 35, 40, 45. So every time it will go according to the target. Okay. It will just speed up. We are now entering the high speed, 60, 65. So you see the speed follows the command closely, and it's only PI control. So the bottom part is the P and I. They are the P and I values. So our maximum speed is 80. Press again, we'll go down to 20. We go down 10. Take it right down to very slow 5. Okay. Very slow, but still following. Still following closely. Later we can look at the speed graph. Okay, so this is the end. Hello, start again. So this time it is the position PID control. Of course, you must download the position PID software from the files. So we connect the motor, switch on, and then it will quickly go from 0 to the present position of 500. For position PID, we have PI and D full control. Okay, so all the three values of PID are there. So even if we change the position, it will just go back to 500. So anytime we try to interfere, it will just bounce back to 500. So this is the basic function of the PID. This is installed in the front. You can turn this. So every time we press, we increase the position by 100. Okay, we press, and then it will follow very closely. Okay, it will, once you add 100, it will slowly just follow to your target position. The other switch is the -100 position button. Okay. There's a small error of 4 in the position. Probably not tuned that well. Okay, not exactly 700. Okay, we come down. Every time we come down, there's always a small error of 1 to 2. Okay. So if you think that there's a steady state error, we can change the value of I. Okay, we go up, we can't reach 500. Okay, there's due to the friction. So we come down, we can't reach the target by 1 or 2 points, 1 or 2 steps. So if you have time, you can fine-tune the PID values to make it slowly go back to the desired position of 200. We've been waiting for a long time, but still it is 202. You see the recovery time is very slow. Can't really go to 200. It's slowly integrating the value so that it accumulates enough power to push it back to 200. But seems it's not working. Still stays there at 202 instead of 200. Okay, it has improved by 1 point, 1 step. The integration, the I value is slowly working, but it's taking very slow. Probably 0.02, the value is too low. Okay, so let's wait a little bit more. You see, it's overcompensated. It's come down to 199. Now the error is in the other direction, so wait for a long time and then it will come back to 200. Okay, so much for this video. This section is to look at the data installed, the program installed in your PC that can be used to capture the data from the embedded processor, okay, from the controller board. Now top part is the PID values. You can set the PID values from here. and the second line is to set the scale of the graph. Okay, so if you change to 1000, okay, the scale will go up to 1000 from 0 to 1000. The third part is on the set the communication port, okay, the communication between the PC and the controller. Before you do so, you have to check which port is available in your computer. Okay, you check, now COM5 is available, so we install the driver. When we unplug it, you see we do not see the 0 connection, CH340. So we choose the COM5 port, and then so we clear everything. We press this button, and then this will start our data capture. The red line is the target, the blue line is the actual position value. Okay. So previously we set the I value as 0.02, now we increase to 0.1. Okay, once we got this, we press the update of the data to make it update the PID value on your board. And then this is the encoder number. Okay. The red is the command, the blue is on the actual track, okay, the actual value. Okay, once we switch off, it will give the whole history of what happens on the actual track, and then you can use this to drag or extend or retract the time scale. Okay, if you want to change the vertical scale, you need to type on the second line. Say you want to just look at from 150 to 500, you just need to type on these two values, and then it will immediately show on the graph. So you can pinpoint any location of the graph and study it and expand it. Okay, thanks. Hello, today we'll play with the position control. Okay, first we clear everything, reset everything, set our vertical scale to 700 and switch to COM5 for the communication port. PID value, initial values, they are all 0, so we need to set the PID values. So these are the preset values. The command goes to 500. So let's reset. Okay, the processor was working on previous values, so we now want to update our PID values. Now once we type everything, and maximum PWM value to 9000, and then our target goes to 500. So we press that green button, everything will be updated, okay, for the first line. So the command is 500, and then PID position is tracking to 500, and we see that the output is actually jumping from 501 to 506. There are some errors. Okay, now it's 505. Okay, it's coming down, the error is coming down, which is a good thing. Now let us expand the scale and so that we can see more clearly. Okay, expand it to 500. Okay, between 510 to 480. You see the two lines, they are not overlapping each other. Okay, the red line is the command, the blue is the actual path. But slowly they will merge. Okay, because of the eye control. Okay, let's go back to 0. Let's do another thing. Let's go to 800. So we are executing this. You see the red command and then the blue actual tracking will follow. Okay. Now we are set as 400, but the actual value is 399. There's a small error here. Okay, so let's press again. From 400 we go down to 200. Okay, the actual track has overshoot downwards and then slowly come back to the original value. Okay, so because we've increased the I value from 0.02 to 0.1, so the recovery time is faster. Okay, so much. Oh, there's one more thing we can actually look at the whole history and then expand or contract the scale by dragging the timeline using our mouse cursor. Okay, we can drag it as long as you want, or just look at part of the graph, time graph. It is possible. Okay, the software, you can use this. You can look at the transient, expand it, and then we can increase the vertical scale to look at the much larger scale. So very clearly we see the error. Okay, the red command and the blue line is the actual path. Okay, we update. We see there's a small overshoot here. Very clearly we see the we see the overshoot. Okay, so much. Okay, so we'll look at the speed control PID. So let us change the vertical scale first. Go from 100 to 0 now. We can always change this by updating the value. So every time we update, we must press the green button. COM5, remaining at COM5. Okay. So let us start now. Now I connect the processor, switch on the processor board, and then let's look at what happens. Okay, because of the previous speed, that's why it's jumping down and then coming out again. Okay, that was the previous experiment. Okay, and then you see it is following the command closely. So let us update the PI value and the target velocity and then press. Now you see what happens. Okay, now the P is 5, the I is 10. You will see there's a sudden drop and then a sudden increase like this. So the velocity and the actual the command and the actual velocity, there's a little bit of difference here. Okay, but anyway it's still following the command velocity at 80. Okay, we can hear the sound of the motor turning. Okay, so we increase to 80 and then you see there's an even higher error when the speed goes up to 80. Okay, it's vaguely following the command of 80, jumping up and down. Now you suddenly want to take it all the way down, and then you see there's a sudden jumping up and down, okay, so, which is a common thing, okay, but after a while it will follow the target around of 10. So our target is 10, the speed is 10, it is still following it closely. Okay. Okay, we can actually drag and look at part of the curve by using our timeline cursor. Okay, drag, extend, or contract. Okay. So this time we'll look at the hardware circuit of the processor board. It's just on one single page. The top part is on the power supply. The middle part is on the main controller. The bottom part are the interface circuits, including switches and Bluetooth. These are the 4 holes drilled for the mounting of the board. Okay, the definition of the 4 holes drilled. For supply of the processor and the logic circuit of the motor drive, we need a 5-volt circuit, but the current does not need to be very large, so we use a small 5-volt regulator to do the job. This is a self-locking on-off, and then we go to the power supply. This power supply is connected to a diode to prevent wrong connection. Okay. And for the power supply, we include a fuse to protect the circuit from the high voltage. If there's any high voltage goes into the circuit, this fuse will blow up. And then once you go to the circuit, there will be some decoupling capacitors to filter out the AC values. So there will be a big capacitor and a small capacitor, one each looking after different spectrum of the noise to filter all the noise out. For the regulator of the 5 volt, from conversion from 12 to 5 volt, we also add a fuse there for protection. This is the 5 volt sender as a last resort for protection of over voltage. Then we go to the second part. This is just the standard circuit of the STEM processor. Nothing much to say about this. You can just refer to the data sheet. This is again another chip, a standard circuit to drive our DC motor. Okay, input logic circuit, output high power to the motor. Okay, so these are the 2 LEDs to indicate whether the motor is moving or not. So you can see which the motor is turning in which direction. And this is the connection for the Hall effect sensor connected at the rear of the DC motor. So this is the rotary position capture, the lines connected to the board. And the third line, the third row, okay, is on the interface connection. The first one is the Bluetooth chip. The second one is the download chip, the download connection from the PC. And then this is the OLED display. According to a standard OLED display standard circuit. And then we have 3 push button switches as input control to the board. Okay, so this section is to tell you how to upload the program, the hex files from the PC up to the processor board, and then run the processor board for your operation. It is through this CH340, this small chip for the upload task. It's connected between the USB of the PC and to the serial line of the processor. So this is the actual USB containing the 340 chip, and you should connect it to the processor board. Now first you must realize that the jumper connection should all be set to 0 first. Next is the connection. The ground and the 5 volts is a 1-to-1 connection, but the RxD line and the TXD line, you must cross couple them. Okay, it means that from the TX you connect to the RX on the other side, and from the RX you connect to the TX on the other side. So it is cross coupled. Getting it wrong, you will not get the thing to work. Okay, remind you to prepare for your download to this small board, jumper set to 0. Then you connect your USB to the PCB. Now, but before you connect, you must install the USB driver of the CH340 on the PC. So you should try to run and then you then go to here. You see, this is the CPU at the window driver program. Okay, it is supplied in the folder. So you click on this Windows setup, and it will install itself in 1 minute. So after that, you open this, and then you try to find the ports, the available ports to you. So you think, oh, COM5 is available, so now we choose COM5 as the port for our serial transport of the data. For the bottom part, very important, you should set RTS DTR bootloader. Okay, you should set the RTS as low, DTR as low, and must through the bootloader. Okay, then you go to any program. Okay, there are few programs in the list. You could try them. What you want to do is to go through the inside folders and find the hex file. Okay, oh, we got one hex file here. Why don't we try to use this hex file? Okay, it's usually in the object folder. You just go to the object folder. So so we have velocity program, we have position program. So you just go there and find the hex file. So once you've selected, again, originally it was set connection to 0. So to accept the data, the bottom one must be connected to 1. In this case, you will switch on the RAM available to accept foreign data. Make sure you set this, otherwise data will not go into your board. Okay, so then we press this start, and then it will go up and slowly upload the data to your processor board. The BPS, the communication speed, there's no need for adjustment. Okay, so if it is successful, it will give you all the status saying that everything is done. A message similar like this shown on the screen. Okay, so once you do that, it is already successful. So let's go back to this one now. Because you accept, you should now switch it back to both 0 because you want to protect the program. So once you switch it back to 0, it is stop receiving data. Okay, then you go to the operation mode. So from then onwards, you can start to go to operation. Okay, so these are the programs that is available in the folder. Remember to install all these drivers first, otherwise you will not be able to switch on. Okay, especially on the USB driver. Okay, you need to switch it on. Okay, thank you.